Today we are going to learn the topic of anticoagulants. We are often confused between these three. First, we have something called as the high molecular weight heparin, which is also known as the unfractionated heparin. This is the first thing. Then we have to differentiate it with low molecular weight heparin and ultra low molecular weight heparin. These are three things available to us. First is the high molecular weight heparin or the unfractionated heparin. So there are certain points of comparison between these three. First, the example. Obviously, the example of unfractionated heparin is just heparin. The route of administration of heparin is IV and subcutaneous, both routes. Then this heparin is metabolized by liver. It inhibits mechanism of action of heparin is that it inhibits factor 10 and factor 2 equally. So there is equal inhibition of factor 10 and factor 12. And we require monitoring when the patient is on heparin. For monitoring, we do APTT, serial APTT monitoring of the patient. Then they increase this risk of HIT. What does HIT mean? Heparin induced thrombocytopenia. So there is increased risk of HIT with high molecular weight heparin, and we have a specific antidote available for in case there is toxicity with heparin, that is protamine sulfate. So we are going to contrast these features of heparin with other newer classes of heparin. Like the second is low molecular weight heparin. Now low molecular weight heparin, the example of low molecular weight heparin is the drugs end with a suffix parin. So we have drugs like enoxaparin. This drug enoxaparin is very commonly used in COVID in form of drug known as flexin. So we have parin class of drug or the low molecular weight heparin which have a suffix parin. They can be administered only subcutaneously. So low molecular weight heparin route of administration only subcutaneous, not both. Then this is metabolized by kidney and not liver. So in case the patient has kidney failure, we'll shift the patient to heparin. So this is the reason why when a COVID patient is on flexin, that is low molecular weight heparin, we do serial serum create. So it is metabolized by kidney. If the patient has kidney failure, we should shift over to normal heparin. Since it's metabolized by kidney, it is contraindicated in renal failure. But if we are to give this drug to a patient of renal failure, we have to do monitoring of factor 10. As to why factor 10 monitoring, because the mechanism of action is such that it inhibits factor 10 much more than factor 2. So there is no need for monitoring of APTT. We can directly monitor for factor 10, which is the major factor inhibited. Then in general, the patient does not have any kind of renal failure, does not require any monitoring, which is contrast to this conventional heparin which requires APTT monitoring. There is definitely a risk of HIT, but it is much less as compared to high molecular weight heparin. And protamine sulfate acts as a specific antidote for this low molecular weight heparin as well. Now this low molecular weight heparin is synthesized by fractionation of this high molecular weight heparin. Now we have another class, the synthetic heparins, which are ultra low molecular weight, and these start with this suffix parinox, like fondaparinux, idaruparinox, like that. These are given only subcutaneously, just like low molecular weight heparin. They are metabolized only by the kidney. This is contraindicated renal failure. If they are given renal failure, we require we monitor the patient by using factor 10 assay. They are highly selective and they only inhibit factor 10. They do not require any kind of monitoring. There is no risk of HIT with these, and there is no specific antidote available. So you should contrast and compare between these three classes of drugs. We often get confused between these.